The first thing we're going to do is actually an experiment on freshness, bread freshness. When we're finished with this, I would expect you to write a science report of 1 or 2, 3 paragraphs, and I'll be sharing that at the end of the lesson. All right, so how does a scientist think? Well, we like to think by using numbers to solve a problem. So we start with a question, we make a hypothesis, we think about the variables, how it could be a fair test, that we could test the hypothesis. We do a procedure where we collect data, we analyze and look at the data, and we come to a conclusion to see if our data supports our hypothesis. Scientists use math, that's the language of science, to prove or disprove the answer to their question. So right now, you have we're going to do a bread freshness activity. So let's look in your books right here. It's turned to page 12. Anytime in this book you see an inquiry with a yellow triangle, your teacher has all the materials to do that investigation. I challenge the 5th grade at Stout Field to do a lot of these activities. In fact, you might even want to get a video, and there's a video right here in this room. You could videotape these activities, and I'd help you edit them, and we could put them up, and I would use them with different schools. I'm actually doing that on all the grade levels. So 5th grade, that's my challenge to you. What we're going to do today is called, Which Method Keeps Bread Freshest? The first thing we need to do is think about what's going on here. We're going to use 4 slices of bread, and I can draw that, and I'll show you what I'm talking about. There's 4 slices of bread, okay, and half slices, so here's 1 slice. I think you've already cut them. All right, here's my 2nd slice. And my 3rd slice. My 4th slice. So we have 4 slices of bread. And we're going to use this bread in a bread freshness investigation. What will keep bread fresh is our question. One of these we're going to call the control. A control is one we're going to do nothing to, and that's going to be called the control. The other 3, I'm going to call them E1, E2, and E3. Those are going to be our experimental slices. All right? So I want you to, just for a second, most of you have taken a sandwich to lunch, and your mom or your dad or your brother or sister or even you have wrapped that sandwich so it stays fresh. Because you know when you open up bread, it starts to get stale. It gets hard and eventually gets crumbly, and it might even get moldy. So we're going to try to see an experiment of 3 different ways to keep bread fresh. And this is a guided experience. And so if you look in your book, you'll see that there are the different methods that we're going to use. Look at them right here. 1, the first method is we're going to use wax paper. So E1 is wax paper. E2, the second one, is going to be a paper bag. Paper bag. And E3 is going to be a plastic bag. So you might be thinking right now, I've taken a sandwich in a paper bag and in wax paper and a plastic bag. And you might be thinking, which one do you think will stay the freshest the longest? But we have a problem. Scientists like to use numbers. So we're going to use some numbers here. So I want you, teachers, you may want to make this also on the board. We need to make some sort of a fresh bread chart or rubric. Okay? And so this is going to be 1. Okay? 1. And here's going to be 2. And here's going to be 3. This is going to be our freshness scale. Freshness scale. You may want to write this on the board. Okay, so what does really fresh bread, and that's this is going to be the very fresh here. What does fresh bread look like, smell like, and feel like? So a 3, okay? I want you to come up with, in your classroom, with what fresh bread's going to look like. This is rotten bread over here. What does rotten bread look like, smell like? Okay, that's a 1. And in the middle, what is some medium things? So a 1, 2, and 3, that's our scale. This is the freshest. Let me give you about a minute or 2 minutes. Let me give you 2 minutes to talk in your class and to come up with a scale or a rubric for bread freshness. A 1, if it's kind of rotten, you know, and this is completely rotten. I worked this out at another school. It had green mold on it. It was slimy. It had a bad taste. It was dry and brown. Fresh, it was white. It was soft. It was nice. It was springy. And in between, it was a little fresh. It was kind of bouncy. It had a nasty odor. And it was starting to turn green and brown. So with the scale that you have made in your classroom, we'll be able to put some numbers on our bread inquiry. All right, check it out. Let's look here. Here's what you need to do. The first thing, and see how there's checklists right here? I expect you to do this, check it off, write. Do it, check it off, and write. In your group right now, let's look at the first step. I'd like you to talk in your group for about 30 seconds. Which experimental, 1, 2, or 3, do you think will keep the bread freshest? You might have a difference of opinion on which ones you think will keep the bread freshest. So down here, we have the wax paper, which is E1. So you might want to write an E1 right here. Plastic bag, I think that is going to be, well, you can make that E2 or E3. E2. Paper bag, E3. And the control slice, the uncovered slice, that's our control. So you can write C. Now you're supposed to come back in 5 days. So I'd go ahead and put today's date, which is 9/18. You're going to come back in 5 days. All right, I would like you to go ahead and do this page all the way up until we'll do 1, 2, and 2, and get it set up. Now, you should be thinking, what is the job of the control slice? And your answer, which I heard, was that it is used to compare the experiments or the experimental slices. Now, would it be a fair test if we put the control over by the window and the 3 experimentals somewhere in the closet? No, because we want it to be a fair test. All right, I want to show you, before we move on, I want to show you one more thing, and I think you'll get this. Check this out. If I made a graph real quick, here's my graph. Whoops. Okay, here's my graph. And over here is going to be time going this way. And so these are going to be in days. Okay, and here is 1 day, 2 days, 3, 4, 5. Teachers, the group may want to make something like this. And so over here is freshness, okay? Freshness. And I'm going to start up here with a 1, 2, 3. Now, I have a control. Right now, my control is right here. I can make another graph, but I'm going to put my E1, E2, and E3. On day 1, they're all the same. Predict what's going to happen to these. Now, if my control, we think that my control might start doing this. And so it might go down. Do you understand this? If you understand this, that's pretty good. The control. Now the question is, where are the E's going to do? What if one of the E's does this? It goes like this, 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 and then goes down. or maybe one E might go way down. And so this is a graph that shows time over freshness. And that might be something that you might want to do later on in 5 days. We can complete this investigation and see and answer these questions right here. I'm going to switch gears a bit. So that's your bread freshness. It's now time to do an apple freshness. And what I want you to do is get your worksheet out. It looks like this. Get your worksheet out. And the name of this project is Apple Freshness. Go ahead and put your name on it. Let me give you a minute or two, because you want to put the bread off to the side. The bread should be put somewhere in the room off to the side. Turn your books, in your science book, to page 16. And on page 16 is an investigation called Apple Freshness, and it has to do with steps for an investigation. And all investigations that we're going to do this year start with a question about something you observed. What will keep apple slices from turning brown? And that's what I want you to write here on your worksheet. What will keep apple slices from turning brown? Question mark. Go ahead and write that question right from your book. That's our question. What will keep apple slices from turning brown? We're going to investigate that question. So our next step is to make a hypothesis. Will everybody say the word hypothesis? All right. A hypothesis, if you look right here, a hypothesis is a possible answer to your question that can be tested. So I'm going to draw an arrow up to my question, and I'm going to underline tested. And you can learn more about a hypothesis by reading over here. A lot of times it has an if, then, and because statement. So here it is. And this is what we're going to do. If I put lemon juice on the apple slice, then it will not turn brown because the juice keeps the apple from reacting with air. So I'd like you to go ahead and write that right here in your worksheet. Go ahead. If I put lemon We're going to talk about something next called variables, control variables. And if you look, there's a whole section on identifying and control variables. So there's a lot that could go wrong during this apple investigation. We may not even know what's going on. So it's good that we try to control as many. I would like you to write. We'd like to control these because what we really want is what's called a fair test. We want a fair test. Okay? A fair test. So what things are going to be the same? It's from the same apple. We're going to do it on the same day. Same size. Same temperature. Would it be a good idea to put one apple slice by the window and one by the door? I don't think so. We want to keep them the same. That's called controlling the variables for a fair test. Same apple, same day, same size, same place, same temperature. Now we have two other types of variables called the dependent and the independent. So what are we measuring? I bet you know. What are we measuring? We are measuring how brown something is. Brown for freshness. And what is our experimental variable? What are we going to do to one of these? One of them we're going to leave as the control. The second one we're going to add lemon juice to. So go ahead and complete the variables section of your worksheet. The next section, so we're going to have 2 apple slices. We're going to have a card, index card. You're going to have some lemon juice. And that's just about all the materials we're going to use. But just like we did with the bread freshness, we have to come up with a scale or a rubric for our apple freshness. And it looks like this. Here's our apple freshness scale. Now, I need your help. I'm going to ask each class to come up with some of these different observations for this apple freshness scale, all right? And so we have a, let's put 1 here, 2, 3, 4, and 5. 1, and you may want to write this up on the board. So like 1, 2, 3, or 4 observations for our scale. If it's fresh, it's white, it's firm, it's juicy, it's flexible, it smells sweet, all the way to rotten and moldy. Control, slice, and we're going to do nothing to this one. Okay, control, slice, nothing. And this is the experimental slice. And this one we're going to put 8 drops lemon juice. Down below here, we need to leave a lot of room here. So the 8 drops of lemon juice is going to be here, but I want to put a space here so we can make some observations. I'm going to divide this into 4 days. Okay, so on this side, I might even make this one a little bit thicker just so you know that that divides the 2. All right? So today's date goes here. This is 9/18, and this is 9/18. This is 9/19, 9/19. Go ahead and get your card set up like that. And all we need to do now is set the 2 apple slices here and here. Now I'd put these so they look like a boat. I'd set them so that they would rock back and forth. That way you'll be able to put on this one, and I'd put them both like that, so you'll be able to put the lemon drops on just the one, an experimental slice. So let's go ahead and carefully arrange this on your desk and administer the 8 drops of lemon juice. Okay, this is a chart that you can use to graph your apple freshness. Your control, like you can have a C and an E, which is the key for the control and experimental. So both of those, on the first day, the C will be here and the E will be here. Well, we kind of think that what's going to happen is on day 2, that C is probably going to start going down, and day 3, and maybe by day 4, and by day 5, that C should really be, that's the control. And maybe the experimental, let's make that a diamond shape. So they both start up here like that. And we hope that the experimental, because of the lemon juice, maybe it'll stay just a little bit fresher. and maybe by 5 days, it's between a 3 and a 4. And so this is one way that we can use a graph to check our data. So I'd like you to end this investigation by writing these 3 paragraphs here. Paragraph 1, what did you do about bread freshness? What did you learn? What was your question? What was your hypothesis? Paragraph 2, what did you do? What did you learn? What was your question? What was your hypothesis? And paragraph 3, how are they alike? How are they different? What did you learn? What tools did you use? What science methods did you use? And we'd love to get pictures.